So I'm going to talk about the color in cartography and general in visualization, because it's all about the data, in case of cartography in spatial data, and how to make successful color design choices, or maybe avoid the unsuccessful one, and why and how we can do this. And actually, the whole origin of this topic in my research started in the project that we had in our department at University of Warsaw with my great colleagues from my department. And when among many thematic maps design issues, I was responsible for the topic of colors in cartography, thematic cartography. And when I was presenting the very initial results of our research, of my research in this color, I was lucky to meet Arzu Choltekin and during one of the conferences in Tokyo, and she inspired me and motivated me to go deeper into this topic. And even though the project is already finished many years ago, I was lucky to cooperate with her and just to dig deeper in colors. And we still see a lot of research problems, a lot of issues that are worth to investigate. So today I'm going to mainly about this going deeper in this topic that I was lucky to cooperate with Arzu. So when we talk about colors, it is not only about the beauty, about eye grabbing, but it also play very important functions because it helps us to communicate, to show better, easier for the map user, for the user of our visualization, our data. In case of quantitative data, we can see easier the extreme values, we can see easier the pattern, where is the larger values, where are the lower values, and so on. So it helps us to make use of this data easier, to see the patterns and so on. It is also about the emotion and association, because color evokes and brings is able to bring some kind of association, some kind of emotion that are visible together with the data. So it is another power of the color and the appropriate color design. And the importance of color in cartography is really well known, because when you take any kind of handbook, any kind of handbook of cartography, you can see at least one chapter that is focused only about the color, how to design it, what are the rules, why it is important, in what context it is worth to use it, and it should sound, and it is exactly the same case in information visualization handbooks. So it can feel that one can feel that it is all clear and it is all obvious. The color is not a problem, because if it is so easily available, this guidance, there is really no problem with this color design choices. But actually it is not so easy, as Arzu mentioned at the introduction, because there are also some kind of controversial design choices that are really the subject of high and sometimes fierce debate. And the best example of this controversial example is the one that you can see in here on the thematic map. So it appears the colors that are really fully saturated, that grabs our attention, but it can be applied in azoline maps, in choropleth maps, in any kind of thematic map types. But it is also, we can also see it in visualization information data. And it is still colors that are meant to tell us about the values. Yes, so we still talking about visualizing quantitative data. And this color design scheme is called rainbow color scheme. So this is this controversial one that has people that really are against using it, and the people that are really go into this solution. So rainbow color scheme is the one that are consisted of fully saturated colors. That is in sequence according to how it appears in electromagnetic spectrum. So we've got a lot of colors, a lot of view, all of them are fully saturated, so we can feel that it is really grabbing the attention of the user, but actually there are a lot of problems connected with this color scheme. When we think about what color schemes should be good, what color designs can be good, we can consider so-called good color scheme standards developed some time ago. So it was indicated that if the color scheme is good, it means that it should present in a proper way order, change in a uniform way along the color scheme. It should properly represent distance, do not create false boundaries. We can also think about the color vision deficiency, so it means the inclusive design. So when we think about the color scheme in terms of these standards, and the first one presenting the order, when we select several hues from the rainbow color scheme and we think which hue should represent the higher value and which one the lower value, it is not really clear in some cases, even though it is taken from the rainbow color scheme that is applied for the quantitative data. It is not really clear and intuitive in terms of this order. And we also provided the empirical evidence about that, because we conducted empirical study, user study with more than 500 people, and we asked participants to order these squares in a sequence that starting from the one that should represent the lowest value and ending till with one that should represent the highest value. And it was really not so easy for the participants, because it turned out that the participants provided more than 100 different sequences. So it was really confusing for them how to order it, and actually the accuracy for this task was below 30%. So it was really really low. So another standard for this good color scheme is about the uniformity. So it means how it changes along the color scheme. So again, when thinking about the rainbow, and when we select hues in an equal interval from the scheme, when we compare these pairs of the hues, we can use the mathematical formula that was developed to show the perceptual distance between colors. And we see that the values changes a lot, ranging from the 18 till the more than 60. So even though it was taken in a constant distance from the color scheme, the perceptual distance is completely different. So again, the rainbow fails in these terms. And again, when we think about the creating false boundaries, we see that when representing exactly the same set of data, we can see that in this place, we've got some kind of boundary, because we've got a rapid change in the colors. And actually, when applying the same data and showing the same data with different, more recommended color schemes, there is no such boundary visible. So it was only the artifact created by this color scheme design. And when thinking about the color vision deficiency, we also see that in many cases there are parts of the colors of the rainbow that can be perceived as exactly the same, or really hard to distinguish for many people that have a color vision deficiency. So if we see that the rainbow fails in many cases. We see that it is not recommended in the handbooks, but there is also the really high debate about it. So we wanted to see how it is visible in scientific communication, so it means in established journals, and how often it is applied in papers published in established journals. And we also wanted to check out what is about the empirical evidence from the user studies. So we realized that in many disciplines there was already conducted analysis how prevalent rainbow is in scientific papers in various disciplines, ranging from neuroscience, geography, information visualization, hydrology, or remote sensing. It was conducted by different authors, so it had different conditions of analysis. So there was a different sample size of this analysis, different way of calculating this prevalence. But even though these conditions were different, all of the analysis concluded in a similar way. There is a lot of rainbow in a highly established journals, in scientific papers, even though it is advised against its use. So we also wanted to check one thing, because information visualization community is the one that has the most visible debate about the rainbow, about these negative consequences of using it. And the analysis in this publication was conducted almost 20 years ago. So we wanted to check if it is still such prevalent solution, or maybe it was changed because people reacted from this and learned from this debate. So it was possible thanks to the excellent tool, because it was for the IEEE visualization conferences publication, it was developed an excellent tool, online tool that collects all of the images from all of the publication from the IEEE visualization conferences proceedings. So we, thanks to this, we analyzed almost 30,000 images from more than 3,000 papers. So our analysis covered the range of since 1990 till 2020. So we were able to compare how it changes along this time span in terms of using rainbow. So we realized that in fact the information visualization community learned the lesson and moved away from using it. So the frequency of using rainbow really gradually decreased a long time. But when we compare to other disciplines, we can see that it is still prevalent. It is still often color choice for publication in other disciplines. So we can, when we compare with neuroimaging, hydrology, etc. And we also wanted to see, as I mentioned, the empirical evidence for the how it is successful or not when we use this color solution. So we collected more than 20 empirical studies that was collected along really nice time span, because ranging from 1960 till the recent years, actually. So it is a lot of them, mainly recently, but still really nice the set of papers and set of studies. And again, it was obvious that the condition of evaluation was slightly different in terms of the visualization types applied, color scheme that were compared to rainbow, number of participants, and so on. And we also realized that the rainbow in empirical evaluation are doing better or worse or similar. So the outcomes were really mixed about it. So we were considering what might be the reason. And when we think about how it works or not in our visualization, we can consider three factors, design factors. So in terms what display we apply, what color scheme we apply, and so on. We can consider human factors, so individual or group differences. But also we can think about the task-related factors. So it means for what purpose it is designed, this visualization that we would like to evaluate. So when we consider these three factors, we realize that in fact, in terms of this color scheme design, the task type matters. If we think about the reading details, so extracting the specific values from the visualization, rainbow was doing really good or in a similar effectiveness compared to the other tested schemes. But when we think about the operation of pattern, about thinking about the communicating the order, comparing perceptual distance, we can see that the rainbow is a bad choice. And we also realize that people in general like it and think that it is easy to read, trust this rainbow color scheme, so subjective metrics works really well. So as a conclusion, we can see that the rainbow, the debate resulted in moving away in a visualization community, but it is still visible in other disciplines. And when we think about the color design, we should consider what type of operation, what is the purpose of our visualization. When we got the the purpose of reading the exact values. The rainbow supports this task because we've got huge of highly discriminable features. But when we think about the searching for the patterns, comparing about the distance, so Rainbow doesn't support this operation. But if anyone would like to and really insist on using Rainbow, you always have to remember about the legend. This is the essential element. But as a takeaway message, I think that I can see that color design choices should be taken really in a careful way. So it should be based on the theory of colors and based on the empirical evidence. And not every eye-grabbing, attractive color scheme is the correct choice. Not every popular one, so not every that we see often is the correct one, and not every default setting in our software that we use for the visualization is the correct one. And we can also consider using the online support in color design, because there is available a lot of such support. Instead of just analyzing many of them, I can recommend the excellent web page that collects a lot of excellent application tools, toolkits, platforms that are meant to data visualization. And among many kinds of them, we can see also that there are tools for colors. In general, this web page is run by Andy Kirk, and it is updated for over 10 years, and it really works. It is really active and updated web page. And so when we go into this color section, we can see that we've got almost 20 excellent tools that helps us design our colors. So I really recommend just to check out which one works for you and just support our own color choices with these tools. So if you would like to read some more details about the research that we conducted, I can recommend the open access papers that we already published, and here are the references for the studies that I mentioned. So thank you very much.